So one of the questions I've always asked myself is, we have all these thousands of gallons going through our heart and our vessels every day. These are oiled, myelinated walls. Why does plaque and stuff stick to an oiled wall? It never made sense to me how heart disease forms. And so when we talk about the glycocalyx, think of like a hardwood floor, and then I put a shag carpet on top of the floor. So now as I walk across the floor, the shag carpet is protecting the floor. So I'm not scratching the wood itself. Yeah. So the glycocalyx is like a fur or a hair, like a Teflon coating hair.
It's a
and it's coating the entire surface of the inside of those vessels. And it's basically directing the flow of blood through the vessel, but keeping it off the wall of the vessel so it doesn't damage the wall, cause scarring, cause proteins to stick to the wall, or plasma to stick to the wall, or the white blood cells will find an area where the glycocalyx has been worn down.
Right.
And that white blood cell will then stick to the part of the bare
it's trying
vessel wall.
It's trying to repair that inflammation.
Try to repair that inflammation. So we can clearly see that when people lose that glycocalyx, those are the areas of the vessels that get damaged.
Right.
Correct?
Yeah, that's exactly right. And so the glycocalyx really consists of two things. So you have the endothelium, which is micro thin, and then
one cell layer thick, right?
One cell layer thick. And then attached to that is this sulfated polysaccharide matrix that look like the little hairs you're describing.
Right. And we can show a picture of that.
And you can show a picture that you can see that on the videos you're going to have them look at.
Yeah.
But then suspended in that is this gel matrix that's like 98% water. Mm-hmm. And so in the capillaries, and this is what Hans had to figure out, and it took him a very long time to do it, and you can give him a link to watch the videos, and he'll explain it if you want.
Yeah, that's glycocheck.com.
Glycocheck.com. Mm-hmm. And then in the capillaries, what they learned is the capillaries are actually filled with this gel matrix. And so it gets into your capillaries. They're not all active at the same time. And so what we started to measure, and as we learned more science, is we would figure out what's the capillary density. So like you were describing, when you're really young, you've got a whole bunch of them, right? Yeah. And that's why you're really
blood's
healthy.
Flowing through all of
blood's
the little
flowing
ones,
through
yes.
all of them, and then your body regulates and controls. So if I'm just sitting and relaxing, I don't need blood to be flowing through those all the time. But if I start running or my brain starts needing to process, then I need more blood flow because I need to get more oxygen.
You need to recruit more blood.
I need to recruit more blood to go to those areas, and the body regulates that. Well, what happens as we age is we start to lose that. And so most people, by the time they get to our age, they could be running around on 30 or 40% of the capillaries that they started out with when they were young. Wow. And so we coined the phrase is that your organs are slowly starving and you don't know it.
That's right.
And so all of this happens gradually over a very long period of time. But there are things that can accelerate that. A virus, infection, COVID-19 is a perfect example.
Now, you've done lots of studies on COVID with Glycocheck and with the endocalyx, correct?
Yeah, we're doing some studies on both those right now, but we published a really great paper, and it's on our website at glycocheck.com for those that want to go look at it. And it was published in Angiogenesis. Mm-hmm. And what we showed is that in COVID-19 patients, and we looked at patients in the ICU, and we looked at the severity of what happened to those. And then with the Glycocheck, we were able to manage how much of their microcirculation was compromised. And we found that the people that were the sickest that actually had to go on ventilation and stay in the hospital. So those people that recovered from the ICU and came home had a healthy glycocalyx, were within acceptable ranges. The longer they stayed, and if they were on ventilation, those people lost 95% of their smallest capillaries. By smallest capillaries, I'm talking 4, 5, and 6 microns. Those are true capillaries. So to put that into perspective, a red blood cell is 7 microns. So when these are going through, they're going through single file, and they're actually squishing and going
squeezing
through,
into that vessel,
squeezing into that capillary, and they're going through that glycocalyx. And what happens is the virus attacks that glycocalyx, and it's just like sepsis. We just published another really important paper in Critical Care a couple of weeks ago. And what we showed there is that we can measure, and we tied it to all of the normal values that they do in the ICU. So SOFA scores, they're looking at the things that they can detect in the blood. And what we found is we could predict with 100% accuracy, we could look at the microvascular score, those that had 4 or fewer organs that were failing, and those that had 4 or greater organs that were failing, and everything tied specifically to the microvascular health score that you're able to measure on people right here in your office.
Man, that's so awesome.
Yeah.
That is so awesome. So let's talk.